So welcome to B.Tech. So in the previous session we have discussed force exerted by the jet on stationary, flat and curved plates. Now we will solve some important numericals on these concepts. So let us see one problem. So find the force exerted by a jet of water of diameter 75 mm on a stationary flat plate when the jet strikes the plate normally with a velocity of 20 meter per second. So if we had seen here the given data in the question, he had given the diameter of the jet, right, and he had also given the velocity of the jet. And the one more important condition is here, we have to check what is the whether the plate is stationary or whether the plate is moving, and we have to check whether the plate is curved or whether the plate is flat. So whether the plate is curved or whether the plate is flat. So if we had seen here the plate is stationary and the plate is a flat type plate. By reading these things we have to remember our empirical formula, which is m dot into initial velocity minus final velocity. So let us solve this question. So the given data is the diameter of the jet is given, the diameter is 75 mm. So we have to convert this mm to meter. How to convert mm to meter? So as we are well aware of that, 1 mm is equal to 10 to the power minus 3 meter. So 75 into 10 to the power minus 3 we will get 0.075 meters, right? Next we have to find jet area. So jet area pi by 4 d square. So how this empirical formula had get? So if we see in here, the jet looks like in the circular shape. So in any member having diameter d with circular shape, we will get area formula as area A equal to pi by 4 into diameter square. So area A equal to pi by 4 into diameter square. So A equal to pi by 4 d square. If I substitute the diameter d value here, which is 0.075 meters, we will get this value as 0.004417 meter square. Next, the velocity of jet is given as 20 meter per second. So the formula for the stationary plate is F equal to rho A V square. So where here rho is 1000 kg per meter cube, it is a density of water, a fixed value, and if I substitute the same in the formula, F equal to rho A V square, so it is 1000 into 0.004417 is the area of the jet into V square, that is 20 square. So if I solve this, you will get the value as 1766.8 newtons. So if we see units, how to remember units? So units for force will be newtons, units for density will be kg per meter cube, units for area will be meter square, units for velocity will be meter per second. So these are the important units we have to remember while solving the numericals. So if units are not in this state, we have to convert it from SI to CGS or something else. Next, let us check one more problem, but the small change in it is, let us see the question. So water is flowing through a pipe at the end of which a nozzle is fitted. The diameter of the nozzle is 100 mm and the head of water at the center of the nozzle is 100 mm. Find the force exerted by the jet of water on a fixed plate and the coefficient of velocity is 0.95. So if we had seen, the question is somewhat twisted here. So he is not directly giving the velocity value, he is giving the head. So what is head? So to solve this question, we have to know the principle of nozzle. So what is the nozzle principle? The nozzle will convert potential energy into kinetic energy. So the diameter of the nozzle is given, which is 0.1 meter. This is not the diameter of the nozzle. And here also the nozzle diameter given is 100 mm, that is 0.1 meter, and the head is given as 100 meter, right? And the coefficient of velocity CV is also given as 0.95. And if we had seen, as the diameter is given as 0.1 meter, so directly we can find area. So by using the formula pi by 4 d square, and we got area as 0.007854 meter square, right? So how to find velocity? So we had one formula to find velocity when coefficient of velocity is given. So what is coefficient of velocity? Coefficient of velocity CV is equal to actual velocity by theoretical velocity. Okay, actual velocity by theoretical velocity. So if we see here, so we use V actual velocity. So V actual will be coefficient of velocity into V theoretical. V actual is equal to coefficient of velocity into V theoretical. So coefficient of velocity is 0.95, which is given in the data, and theoretical velocity is root 2gh. How this root 2gh came? If we remember the formula, how this root 2gh came? So potential energy mgh is equal to half mv square. So if I substitute this, we will get V as root 2gh. So if I substitute in this formula, V actually equal to 0.95 into root 2 GH. So we will get the actual velocity. So when I know actual velocity, I can substitute in the formula rho A V square. So rho is the density of the water, which is 1000, and area is just we have to find out with the value is 0.007854 meter square, and the velocity just we have to find out here by the formula quotient of velocity into V theoretical. You will get V actual, and the actual value is 42.08 meter per second. So if I substitute here, you will get F, and that F value is 13907.2 newtons. We may convert it into kilonewtons also. So how to convert it to kilonewtons? So by multiplying the value into with 10 power minus 3. So by multiplying the newtons value with 10 to the power minus 3, we will get it in kilonewtons. Okay. So this is the numerical. So students, till now we have discussed about the plate in vertical position. Now let us discuss a numerical when the plate is in inclined position. So this is the numerical on inclined position. So let us read the question. A jet of water of diameter 75 mm moving with a velocity of 25 meter per second strikes a fixed plate in such a way that the angle between jet and the plate is 60 degrees. Find the force exerted by the jet on the plate in the first question in the direction normal to the plate and in the direction of the jet. So for every numerical, if you understand the question easily, then we can solve the numerical very easily. So if you see, let us see the given data in the question. So in this question, water diameter of 75 mm is given, right? And it is moving with a velocity 25 meter per second. It is also given, and here also he is also given here the angle between the jet and the plate is 60 degrees. So from this we can easily say the plate is not vertical plate, it is inclined plate. That means, so this is our jet and this is your plate, right? And the angle between the jet and the plate is 60 degrees. Fine. So what he is asking to find the force in normal direction, that is our Fn, and he is also asking to find the force in the direction of jet. So what that means, x axis. So here this is x axis and this is the y axis, right? And this is the normal direction. So we have to find the force in normal direction and the force in x direction and the force in normal direction. Okay. So let us see. So the diameter is given, yes, which is 75 mm. When you convert it into meter, we will get it as 0.075 meters, right? And area is given. So area is not given, diameter is given. Indirectly we can find area. How? So when the diameter of jet is known, we can find it from the formula A equal to pi by 4 d square, right? So this is the area value, and the value is 0.004417 meter square, right? And the velocity of jet given is 25 meter per second. So and the angle between the jet and the plate is also 60 degrees. So these are the four data given to us. Now what we will do, so the first bit he is asking to find Fn. So what is the formula for Fn? If you remember the empirical formula, it is rho a v square sin theta. If you don't remember the empirical formula, then also you can derive it instantly. Let us see, for this sum I will explain how to derive the formula instantly. So for every sum we will write the formula directly. So if the formula is not given to you, so please remember the basic formula. Force F is equal to m dot into initial velocity in the direction, okay, direction, minus final velocity in the direction, right? So this is rho a v. So if you know velocity, so in this sum the velocity he is asking to find in which direction? He is asking to find the velocity in normal direction. So I have to write n here. Okay. So what is the velocity in normal direction? So if you remember the diagram, so in normal direction the jet enter the velocity with v sin theta, right? And what about final velocity direction? So in final velocity the jet is not having any component in normal direction, so this will be 0. So you will get rho a v square sin theta as Fn. So this is the way to derive the empirical formula. So if you see here, Fn equal to rho a v square sin theta, where rho is the density of the water, which is 1000, and a is the area, which is 0.004417 meter square, and v is the velocity 25 meter per second directly given in the question, and the angle is here 60 degrees. So sin 60. So if I solve, I will get the force exerted by the jet in normal direction as 2390.7 newtons, right? So similarly, we have to find the force on the jet in x-axis also. So what is the formula for x-axis? So if you remember the diagram, see, so this is my inclined plate, right? So this is x-axis, this is normal direction. So this is my theta. So this is my Fn value. So this is your Fx value. So how to get Fx? So this angle is 90 minus theta. So if I resolve Fn along the x-axis, then I will get the formula, which is nothing but Fn equal to Fx cos of 90 minus theta. So if you see here, so if you substitute Fx equal to Fn cos of 90 minus theta. So what is Fn? We know that just we have seen rho a v square sin theta. So what is cos of 90 minus theta? Cos of 90 minus theta is sin theta. So this is your sin theta. and if you multiply sin theta into sin theta, you will get sin square theta. You can directly use this formula, or you can remember this formula. It's your choice. So Fx equal to rho a v square sin square theta. So rho is 1000, area is known, velocity is known, and theta is also known. If I substitute here, we will get the value as 2070.4 newtons, right? So let us see now. Till now we have discussed about the problems on a flat plate, which is in stationary vertical and stationary inclined. Let us discuss the numerical on curved plate, right? So let us read the question. A jet of water of diameter 50 mm moving with a velocity of 40 meter per second strikes a curved fixed symmetrical plate at the center. Full stop. Find the force exerted by the jet of water in the direction of the jet if the jet is deflected through an angle of 120 degrees at the outlet of the curved plate. So if you see the question, in the question he is giving the jet diameter, right, which is 50 mm, and he is also giving with a, it is moving with a velocity 40 meter per second, and he had mentioned the plate is curved plate, right, and he had mentioned the plate is fixed, that is stationary, and he had mentioned the plate is symmetric. So whenever we see symmetric, we should remember that theta at inlet is also, so if we had seen the plate is curved plate and it is fixed and it is symmetric. So what is symmetric? Symmetric means theta is same at inlet and outlet, right? So, and he is also given the jet is deflecting through an angle of 120 degrees. See, this 120 is not the angle between jet and plate. I am stressing again that theta 120 is not the angle between jet and the plate. Here the angle is deflected angle. So the angle of deflection, the relation between angle of deflection and theta is angle of deflection is equal to 180 minus theta. So this is our angle of deflection. What is theta? Theta is the angle between jet and the plate. So whenever angle of deflection is given, we can find the theta with this formula 180 minus theta. So if you see here, diameter is given 0.05 meters. So from this we will find area by using the formula area equal to pi by 4 d square, and velocity is given, and the angle of deflection is also given, which is 120 degrees. But how to find theta? So angle of deflection is equal to 180 minus theta. So the 120 degrees given here is angle of jet, the deflection angle of deflection is equal to 180 minus theta. So from this we can find theta as 60 degrees. So we all know for a curved plate which is hitting at center, Fx is equal to rho a v square of 1 plus cos theta. So rho a v square, rho is 1000, area is a is area of the jet, v is velocity of jet, and theta is the angle between the jet and the plate. So which is 60 degrees we had solved now. So if you substitute everything, we will get Fx as 4711.15 newtons, right? And let us see the one more question on the same topic, curved plate. If we have seen here, a jet of water of diameter 75 mm moving with a velocity of 30 meter per second strikes a curved fixed plate tangentially at one end at an angle of 30 degrees to the horizontal. The jet leaves the plate at an angle of 20 degrees to the horizontal. Find the force exerted by the jet on the plate in the horizontal and vertical direction. So while watching this video, just pause for 1 minute and read the question yourself and try to solve it on your own. So let us see the question now. So if you see, the jet of water is, the diameter of the water given is 25 mm, right, and it is moving with a velocity of 30 meter per second. Okay. Next, the jet is striking the curved plate. The plate given is curved plate, and the plate is also fixed, that is, it is stationary, and where it is hitting, whether it is hitting center or tangentially. So from this question we can see it is hitting tangentially. Okay, at what angle? At an angle 30 degrees. While entering it is 30 degrees, and while leaving 20 degrees. So which type of plate? Is it symmetrical or unsymmetrical? It is unsymmetrical because of entering angle is 30 degrees, exit angle is 20 degrees. So both are not equal. Then we can easily say the plate is unsymmetric plate. So he is asking to find the force in a horizontal direction, that is, horizontal means x-axis, Fx, and he is also asking to find the force in y direction, Fy. So let us solve the question. So whenever the diameter is given to us, we will convert it into meters, yes, 0.075 meter, and area is also given to you. So the area is pi by 4 d square formula. So we will get the area value as 0.00417 meter square. Next, and the velocity of jet given is 30 meter per second, right? So here angles is also given, the angle at entry angle, that is the angle between jet and the horizontal axis. Horizontal axis means plate axis. So if we see, this is my curved plate, right? So this is my horizontal axis. So the angle between the horizontal axis and the jet at entry is 30 degrees, and at the exit it is 20 degrees. So he is asking to find the force in x direction, that is Fx and Fy. So what is the formula for Fx? If the formula is rho a v square cos of theta plus cos phi. If it is symmetric plate, the formula will be rho a v square cos of theta plus cos theta. As it is unsymmetric plate, the formula will be rho a v square cos theta plus cos phi. So if we substitute everything, rho a v value and cos theta cos phi value, so we will get the answer as 7178.2 newtons. And if we solve Fy, the formula will be rho a v square sin theta minus sin phi. So if we substitute density value, area of jet value, velocity of jet value, and theta and phi value, so you will get your Fy as 628.13 newtons. So this is how to find Fx and Fy for a unsymmetric plate also. So one thing is, in this question, he had not mentioned the plate is unsymmetric, but by seeing the values as the entry angle and the exit angle are not same, so we can assume this plate is an unsymmetric plate. So till now we had covered some numericals on plate, that is the curved plate and flat plate, and in stationary position. So in the next topic we will continue about the moving plates. So thank you everyone.